Good afternoon, everyone. It is my great pleasure to warmly welcome Dr. C. Nagaraja Kumar, Professor in Department of Physics at Punjab University, Chandigarh, as our esteemed external expert for today's PhD Viva. Dr. Nagaraja Kumar completed his PhD in Theoretical Physics from the Institute of Physics, Bhubaneswar, one of the India's premier research institute. He subsequently carried out distinguished postdoctoral research at PRL Ahmedabad, ISC Bangalore and University of Hyderabad, further enriching his academic journey with an international research fellowship in Germany. His research expertise spans theoretical high energy physics, nonlinear dynamics and supersymmetric quantum mechanics, areas in which he has made notable contribution through his publications and scientific mentorship. Over the years, he has established himself as a respected scholar and teacher in the field of theoretical physics. With his vast academic expertise, deep subject knowledge, and commitment to scientific excellence, we are truly honored to have him with us today. On behalf of the department and the university, I extend a warm welcome and respectful welcome to you, sir. We look forward to your valuable insight and guidance throughout this session. Thank you, sir. You can start.
Good afternoon, everyone. I am Sahit Kumar, pursuing my PhD Shankar Dayal Pathak. Previously, he was there, and currently he is working in MIT University, Lucknow. And the presentation of my the topic of my presentation is the role of dynamical dark energy in the structure formation. If we brief it some introduction, after Big Bang, there is the cosmic inflation, and there is the formation of fundamental particles like proton, neutrons, then there is nucleosynthesis, then matter-dominated era, recombination, formation of cosmic structures, then there is dark matter, dark energy, and now today there is continued accelerated expansion. Expansion of universe. As you know that the accelerated expansion of universe is supported by a number of cosmological observation, and there is one remarkable form of dark energy that is responsible for this accelerated expansion of universe. Because of its one remarkable feature that it possesses negative pressure because of its repulsive gravity. So as per our cosmological principle, this is the basic fundamental principle that says that our universe is homogeneous and isotropic at large scale. With the metric, here we can choose a metric using C equal to 1. This is our basic fundamental line metric element equation, that is ds square equals to g mu nu dx mu equals to minus dt square plus a square t dr square upon 1 minus kr square plus r square d theta square plus r square sin square theta d phi square. Here g mu nu is the metric tensor, at is the scale factor, and r theta phi are the spherical coordinates, and k is the curvature. Here the value of k depends upon three values, that is, if we take a value of k plus 1, that represents our closed universe, and if we can take k equal to 0, that represents our flat universe, and if I take k equal to minus 1, that represents open universe. So here for my research work I have used k equal to 0, that is flat universe. This is the basic fundamental model, that is Friedman, Lemaitre, Robertson-Walker model. This is actually a successful theoretical framework proposed by these scientists based on general theory of relativity. This is the Einstein field equation. So Friedman, Lemaitre, by using the line metric, solves two equations. This is Friedman first equation, and this is second. So Friedman's first equation tells us about expansion of the universe, how universe is expanding, and this is the Friedman's second equation that tells us how our universe is accelerating. So we know that for the acceleration, there should be condition that a double dot should be greater than 0. So for this, we have to set that rho plus 3p should be less than 0. And this leads to the equation of state W should be less than minus 1 by 3. This is the energy momentum conservation, that is a relation rho dot plus 3h rho plus p equal to 0. And from this equation, we can solve energy scaling solution, that is rho naught a upon a naught minus 3 1 plus w. So here we can conclude three results, that is for matter dominated universe, energy density leads to a to the power minus 3, and for radiation dominated universe, rho should be a to the power minus 4, and in case of dark energy, that should be constant. This is the data before Planck and after Planck. Before Planck, there was 72.8% dark energy, and 22.7% dark matter, and 4.5% ordinary matter. And after Planck, that is Planck data, 68.3% is the presence of dark energy in the universe, and 26.8% is the dark matter, and 4.9% is the ordinary matter. So dark energy. So as you know that dark energy is the hypothetical form of energy, and it has this one of the remarkable feature that it possesses repulsive gravity. Because of this, our universe is accelerating. So there are some non-interacting models here, like lambda CDM model, quintessence, tachyonic, and phantom. So as I have already discussed in my previous slides, that there is one remarkable feature of dark energy, that it is characterized by negative pressure, and this is the relation that P should be less than minus 1 by 3. So for dark energy, we should choose a simplest model that we can call cosmological constant, and here this is, and for this model, this should be conditioned that P lambda should be equals to minus rho lambda, and with equation of state, that is minus 1. These are some non-interacting dark energy models. First is a cosmological constant, second is quintessence dark energy, and third one is phantom dark energy, and fourth one is tachyon dark energy. And this is the pressure, that is a cosmological constant, P should be equal to minus rho, with equation of state minus 1. And for quintessence dark energy, P phi equal to 1 by 2 phi dot square plus V phi, and rho phi equals to 1 by 2 phi dot square minus V. And tachyonic dark energy model, this should be our pressure and energy density equations. This is the methodology that I used to achieve my all three objectives. Sir, I used the software like Mathematica and LaTeX for my simplification and manipulation and plotting of the my research. This is the literature survey till date. Sir, in 1998, this was the paper of Rice, who first provided us the first strong evidence for the accelerated expansion of the universe and dark energy. But there are some problems in this model that we can say cosmological constant, like fine-tuning problem and coincidence problems. As you have also seen that in my previous slides, that its equation of state should remain constant, that is minus 1. So for this, scientists do some research and go with like quintessence dark energy. So sir, in quintessence dark energy, there is equation of state vary, and then there is phantom dark energy model introduced, then there is tachyon dark energy model introduced, and then there is latest data of DESI that published in 2020 that show some latest data that we use in here. These are research gaps. As you know that the dark energy is the exotic form, but there is some consistent field theory of dark energy yet is not understood well. And second is the observational signature of dark energy is one of the major challenge in cosmology. So it might be possible that we can explain the structure function through dark energy. And third is the we are going to investigate different alternate model of dark energy that explain the much better results apart from cosmological constant that we use a fundamental dark energy model. These are my research objectives. First is to develop field theory consistent with observation for dark energy. Second is to investigate the role of dark energy in structure formation. And third one is to investigate alternate model of dark energy and construct a model independent diagnostics for different dark energy model. This is the my first work that here we are considering three forms of scale factor. First is logarithmic, second is linear combination of formula, and third one is quasi for different non-interacting dark energy model that I have already discussed with you, that for quintessence, tachyon and phantom. So this is the value of Vt and Phi-t for different scalar field models, that is for tachyon, quintessence, phantom. So what I did here, I put the value of At for different models in Vt and Phi-t to check how to check the qualitative behavior of different scalar field models, and to justify which model fits good to explain the oscillating expansion of the universe. So this is tachyonic scalar field, and this is the Lagrangian of the tachyonic scalar field, that is L equal to minus V phi square root 1 minus del I phi del phi, and from this we can compute the pressure and energy density for the tachyonic scalar field, that is given by rho phi equal to V1 root 1 minus phi dot square, and P phi equal to minus V root 1 minus phi dot square. This is the equation of motion for a tachyonic scalar field, that is phi double dot equals to minus 1 minus phi dot square 3h phi dot plus 1 upon v phi dv by d phi, and this is the conservation of energy, that is rho dot equals to minus 3h1 plus w rho, and from this energy scaling solutions. And for the this is for the tachyonic scalar field, we calculate this relation, that is rho dot upon rho equal to minus 3h phi dot square. From this above equation we solve it, and this is the value of Vt for the tachyonic scalar field, and similarly for the value of Phi-t for tachyonic scalar field. And similarly for quintessence scalar field, this is the Lagrangian equation, and from this we calculate the pressure, and by using all these we calculate the equation of motion for the quintessence scalar field, that is phi double dot a plus 3h phi dot plus dv by d phi equal to 0. And similarly for the quintessence scalar field, by calculating all this, we calculate the value of Vt for quintessence scalar field is like Vt equals to 3h square upon 8 pi g 1 plus s dot upon 3h square, and similarly value of Phi-t for a quintessence scalar field is Phi-t integration of minus h dot upon 4 pi g whole power 1 by 2 dt. And similarly for phantom scalar field, this is the Lagrangian equation, and from this Lagrangian we can calculate that the pressure and energy density for phantom scalar field, and similarly this is the equation of motion for the phantom scalar field, that is phi dot minus dv by d phi equal to 0. This is the value of Vt for phantom scalar field, and value of Phi-t for the phantom scalar field. So here I am taking my first case that I have already discussed, that I choose here three form of scale factor, that is logarithmic, power law combination, and third one is mixed quasi. So I am going to discuss this logarithmic scale factor, how it show the qualitative behavior of different form of scalar field here. So this is the for tachyonic scalar field. This is the value of Phi-t that we calculate here for our work, and this is the, you know that there is a logarithmic growth in this graph as time goes on, and Phi-t increases linearly here. This is the Vt. Value of Vt that we here for this model, and there is a gradual decrease in the value of Vt. Then at the late times it approaches to flatness. So similarly for the quintessence scalar field, this is the phi t and Vt. So here like in the same way here also there is gradual decrease in the Vt, and at late time it goes towards the flatness. Similarly for a phantom scalar field, this is phi t and Vt, and like the same way there is also gradual decrease in the Vt, and at the late times it approaches towards the flatness. Similarly, this is the case 2, that we choose here scale factor power law combination for different non-interacting dark energy models. So this is the for tachyonic scalar field. We calculate phi t here root t naught k whole cube, and this is the dynamical behavior that is represented, that it is increase in value of phi t as time go on, that is justify symmetry. This is for quintessence scalar field phi t that we calculated here, and this is the qualitative behavior that there is increase in phi, and if it approaches towards late time, it is gradual decrease in kinetic energy because it dominates potential energy at the late time here. And similarly for quintessence scalar field, I'm sorry, this is for phantom scalar field phi t here. Like the same way, here is also increase in the phi t, and at the late time it approaches towards the flatness. Like because it's here kinetic energy decreases and potential energy dominates our kinetic energy that justify the control oscillation. This is case 3rd, that is mixed quasi. So this is the for tachyonic scalar field. Here is this is value of phi t, and here is also an increase in the value of phi t as time goes on to the later universe Vt, and there is also a gradual decrease in the value of Vt as time goes on, and at the late time it leads towards the flatness. And similarly for the quintessence scalar field phi t, this is the behavior of qualitative behavior of phi t, that there is the gradual increase in the value of phi t if as the time goes on, and leads towards the flatness at the late time period. And for the quintessence, this is the Vt, and there is gradual decrease in Vt initially, then at the late time it approaches towards the flatted. And similarly, this is for phantom scalar field phi t, and there is also a gradual increase initially, then approaches towards the flatness here at the late times. So here this is the Vt for phantom scalar field. Here there is a gradual increase in initially, then with respect to time, that represents here because of and leads towards big rip in future. This is the conclusion. Here we explored real scalar fields, that is tachyonic, quintessence, phantom as a dynamical candidate of dark energy, and we use here 3 form of scale factors, that is logarithmic, linear combination of power law, and quasi exponential expansion. So for logarithmic expansion, these scalar fields, that is Vt and phi t, shows indistinguishable behavior under the expansion scenario. And similarly for linear power law combination, this scalar field exhibits mixed power law and logarithmic behavior in Vt and phi t. And this form can interpolate between different expansion phases, that is matter dominated and initially and at the late time oscillation. So this is the analysis of my paper, that what is their main significance. So here what we can conclude, that for the tachyonic scalar field model, there is smooth and stable oscillation. And because phi t grows logarithmically and Vt decreases steep at early and flattens at the late times, so it shows a controlled and smooth oscillation for this model. And similarly for quintessence, the potential term dominates our kinetic at late times and leads to a means there is no big rip in this model. And similarly there is for the phantom the phi t grows because of effective kinetic energy contribution, because there is a negative term in the kinetic energy of phantom in its Lagrange equation, and this leads to the superacceleration in this and which leads to the big dip in the future. This is the main work that I have did in my first paper. And this is the second work investigating star formation evolution in the couple Physidium model. So sir, here actually what I did that here, this is the equation of continuity without interaction for Physidium model and dark matter, and similarly with interaction, if I add some interaction, this is the equation of continuity. So sir, if Q is greater than 0, that means we are transferring energy from dark energy to dark matter, and if Q equal to 0, there is no transfer of energy, and if Q is less than 0, it means we are transferring energy from dark matter to dark energy. So sir, this is the interaction parameter that I choose Q equal to 3 alpha rho dot for my model. So this is sir impact of how this interaction term impact in the scalar factor in our that how it behaves. So sir, as I see that this is the our standard model that there is, if I take alpha equal to 0 and equation of state that I choose for my model is minus 1.2, there is a exponential increase in the scale factor as the time goes on, and it mimic with our standard model that is lambda CDM to show consistency. So if we increase that, if we give little bit interaction, that is alpha equal to 0.2, there is slight increase in the expansion rate, that is represented by this red line. And if we give more strength, that is if we again increase the value of alpha 0.89, that there is slight decrease is also in the slow rate of the expansion. That this is the what I got, that if I add some interaction in the non-interactive model, there is the slow rate in the expansion scenario of the universe. The relative growth rate of density perturbation. So this is the density perturbation, that is rho xt equal to rho bar t1 plus del xt. Here del is the density contrast. So from this equation we solve the time evolution of linear perturbation, that is d2 del upon dt square plus 2 a dot upon a d del upon dt minus 4 pi g rho bar del. And from this equation we can solve this del t equals to dt del t naught. Here del t is the density contrast and dt is the represents the linear growth rate. This is the linear growth rate that I have solved for my work. And that is we obtained the growing mode for a model that dt equals to v, this is equation, and you know that there is initially there was more if we moves on, there is slight decrease in this linear growth rate, that is clearly seen from this graph here. This is the qualitative behavior of this linear growth rate. And similarly, I solved the accretion rate of dark matter halos. That is, initially this was very slow. That then there is increase in the this accretion rate if the time if we move to some late time. And similarly, this is the press stator formalism and hollow mass ovulation. Actually, sir, this is the mathematical relation given by these two scientists to explain how hollow mass behave in different scenario of our universe. So here mh is the hollow mass and smh is the variance of the density field at scales corresponding to mh, and del c is the critical density, linear density. This is the growth rate of hollow mass, that is our hollow mass is linearly increasing with respect to time. This is the equation that I calculated for hollow mass equation rate 1 upon mh 10 mh upon del t. This is the cosmic time what I have calculated here, and this is the evolution of star formation. How is there any formation in stars currently or not? This is the total cosmic star formation density can be derived by using this formula here. That is epsilon mh dot tn mh t upon dmh. So here mh is the hollow mass and m dot h is the rate of change of hollow mass, and epsilon mh represents the efficiency of converting hollow mass into stellar mass. This is the contribution of hollows. What is the contribution of these hollow masses in cosmic star formation rate? So this is the equation that I solve here for my model. And so here there is first there is smooth, then if there is increase in the star formation rate with respect to time, and at the late time this approaches there is a stability sum, and then it should decline. This is the conclusion, sir. I here employed the coupled Phi-Cerium model, the interaction between dark energy and dark matter. These are key findings that coupled dark energy lead to a slower expansion rate, as I have already discussed in my previous slides, than the standard lambda. And the scale factor, I take here coupling strength as Q equal to 3 alpha rho dot. That indicating a significant role in the interaction in cosmic evolution. Structure formation. The relative growth rate of dynastic perturbation initially was very low due to strong expansion, but at late time its approaches and effect diminishes. And this is the hollow evolution that we use here. Dependent growth indices to refine model. There are some data from DSC, Euclid and LSST to constrain the coupling parameter alpha and validate theoretical predictions. This is my third work that here I uses alternate dark energy model and dual pay diagnostics, OM3 diagnostics for my model, that is a coupled Phi-Cerium model, and see its effect, how it is shown, if its effect as compared to lambda cerium model. So this is mass varying neutrino scenario. So density, unlike quintessence, epsilon can be heavy because here the mass of is greater than Hubble rate, and this is the energy density of non-relativistic neutrino is given by rho mu equal to n mu mu, where n mu and mu are the number density and a mass of neutrinos respectively. This is the total effective potential for mass varying neutrino, that is V equals to n V mu a plus V naught a, and even if V naught a lacks a minimum, that means n V mu a term induces an instantaneous minimum that varies with time, and since if we take del V upon del a equal to 0, from this we obtain the minimum potential, and so we got n V equals to minus del V naught upon del mv if del mv upon del a is not equal to 0. So this is the equation of state for mass varying neutrino mass, that is W equals to minus 1 plus n V mu upon V, and if W equals to minus 1, and that is if neutrinos energy is small compared to V naught. This is the energy density and pressure density for mass varying neutrino. Here Q is the Combine coordinate and del omega is the distribution function. When the mass of neutrino depends on a field phi, and then by rho v and pv we got this relation, and this is a model is different from quintessence. Actually quintessence is a light scalar field with equation of state less than -1, where mass varying neutrino -1, and it can mimic with the lambda cerium model under certain limits. This is another unparticle dark energy model. Actually, unparticle is the hypothetical form of energy that explains the late time acceleration of the universe, and this unparticle term was first introduced in 2007 by scientist Howard Georgi, that described that they don't have a definite mass unlike a standard particle, because it has property that it acts like an operator with non-integer scaling dimension. And here is one remarkable feature of this unparticle is that it possesses a continuous mass spectrum and interacts very weakly with standard models. This is the Lagrangian of one particle, that is alpha equal to 1 by 2 del mu phi minus v phi, and this is derived mass spectrum ratio, that is du minus 1 upon 2 du lambda mu square, where du is the scaling dimension here and lambda mu is the energy scale of unparticle sector, and this is the effective potential, that is v phi equals to b root rho u phi square. Here b is du minus 1.2 du, and this is the energy density and pressure density for this unparticle, that is rho u equals to 1 by 2 phi dash square plus b rho square root rho u phi square, and pressure 1 by 2 phi dash square minus b square root rho u phi square. This is the what we can conclude here, that this model avoid the same problem. It avoids fine tuning issues that are common in that scale invariance in cosmology, and it's actually a very promising candidate for future observation test, and is consistent with type Ia supernova, BAO and CMB data. And this is the diagnostics that I do for my model, that I take a coupled phi CDM model. These are some diagnostics, that is OM-X diagnostics, OM3 diagnostics and state finder. So first OM-X diagnostics just check the how matter density evolution with respect to time, and third is OM3 diagnostics that probes early inverse behavior, and third one is the state finder that tracks the dynamics via higher derivatives. This is OMZ diagnostics that I do for my model of phi CDM model with for interacting phi CDM model with taking interaction term q equals to 3 alpha rho dot, and this is the OMZ diagnostics can be defined as OMX h square x h upon h naught square minus 1 x square q minus 1, and for the interaction term q equal to 3 alpha rho dot, this is what I got result, that OMX equal to omega naught 1 plus 3 alpha upon 1 minus 3 alpha plus 1 plus omega minus 1 is whole to the power x cube minus 1. So here x is equal to 1 plus z. Z represents redshift. So if we take here the value of alpha equal to 0, so it can make with the lambda CDM model, like that is our standard model. But if we take different endpoint to alpha equal to 0.89, so here is the what variation I clearly represent here in my graph, that if I take alpha equal to 0.2 and omega equal to minus 1.2, so this is the standard model, that is this graph for lambda CDM model. But in term, this can there is slight decrease in the graph. It just provides this very strong evidence that at the late time the quintessence like behavior suits well for my model to explain the late time acceleration of this. This is a conclusion that scalar field dark energy models such as quintessence, phantom, mass varying neutrino and particle provide a very diverse framework for explaining the cosmic acceleration, and also it's provide very great flexibility to explain how it vary as compared to our lambda CDM model, that is our standard model. So how it impact our coupling term. So there is strong interaction term, that is alpha, and that's why it's a very good result avoiding future singularity. If we take alpha equal to 0, this represent our non-interacting phantom. There, if we take alpha equal to alpha 0.8, that is a strong interaction term. It suppressed late time growth, that is, it shows smoother evolution as compared to non-interacting model. This for lambda CDM model, that if we take alpha equal to 0 and w equal to minus 1, OM that is constant, confirming. If we take alpha equal to 0.8 and w equal to minus 1.2, it shows graph rises stiffly, implying the stronger deviation from lambda CDM model, and it should behave like a phantom-like behavior. And if we increase alpha equal to 0.89 and equation of state equal to minus 1.2, that is our strongly interacting phantom model. Sir, here ohms z decreases with increasing z. It showing a non-phantom like or even quintessence like behavior here. So these are the conferences and workshops that I have attended during my PhD work. That I attended my first international conference on advanced functional material and devices that I have attended and presented orally, organized by IQSC and Department of Physics at ARSD College, University of Delhi during 13 to 15 March 2023 via online mode. And sir, I have already participated and presented orally in the 5th International Conference on Recent Advances in Fundamental and Applied Sciences (RFAS), held from 19 to 20 April 2024, organized by School of Chemical Engineering and Physical Sciences, Lovely Faculty of Technology and Sciences, here in Lovely Professional University, Punjab. And sir, I have also attended World International Conferences on Current Advances in Applied Physics from 2021 February, have attended and presented orally, organized by Department of Physics, School of Sciences, Manu, held at Maulana Azad National Urdu University, Hyderabad. And I have also attended one workshop on astrophysics and cosmology at Lucknow, has been done from May 2 to 4, and one presentation was delivered there. And I have also participated in 5th Summer School on Gravity, Cosmology and Astrophysics from 1st July to 8th July, that was held in Russia. These are my publications, sir. I have, this is my first paper, Dynamics of Quasi-Exponential Expansion. I have published it in Journal of International Journal of Theoretical Physics, Despairing Star Formation Dynamics with Coupled Phi-Cerium model that I already discussed in Europhysics letters. And this is my third paper that is under review, sir. A diagnostic study beyond lambda cerium is currently under review in Journal of Holography Application in Physics. This is, sir, my conference certificate that I received, and this is workshop certificates. This is my first paper, Dynamics of Quasi-Exponential. This is my second paper, sir, that I got published in Europhysics letters. And this is my certificate that I attended one international school that was conducted in Russia. This is an acknowledgement. Additionally, I would like to express my sincere gratitude to HOS Dr. Kailash Chugran, HOD Dr. Sir, for their constant guidance and support during my every intern presentation. And I am deeply thankful to Dr. Maxim Kolopo, Dr. Zagbang Zhang and Maninder Sharma, Vikas Kumar Oja, Rupa Mukherjee and Dr. Vipin Sharma for their insightful discussion and encouragement and constructive feedback through my PhD research. Thank you.
Good. Interesting presentation. बहुत टाइम लिया, पानी पी लीजिए.
Thank you, sir.
The first part of the thesis, I have 2-3 questions. Scaling function A of t, you have taken 3 cases. And that really throughout the thing, even...
Yes, sir. Actually, sir, I have plotted the graph of phi versus t in my thesis.
Why?
Sir, actually, it's also showing it...
it won't tell you anything. Potential as a function of phi.
Yes, sir.
You know,
Actually,
phi field theory, etc.,
yes,
etc. There are, every time you find phi as a t.
Yes, sir.
Okay. Anyway, that's slightly a drawback in that sense. You should have done it. V function of t is available, phi function of t is available. So straightforward to plot V as a function of phi. That would have thrown more light into what is the scalar field interaction.
Yes, sir.
Tachyard, कोई क्या होती है?
क्या देख सर, मतलब एक हाइपोथेटिकल फॉर्म ऑफ
क्या फर्क है? रियल स्केल
जो होता है सर, उसमें नॉन कैनोनिकल मतलब हमारा स्केलर फील्ड होता है.
सॉरी,
नॉन कैनोनिकल स्केलर फील्ड होता है. बिकॉज क्योंकि सर उसमें जो उसकी लैग्रेंजियन है उसमें नेगेटिव टर्म आती है, मतलब उसके फाइव डार्क स्क्वायर की, मतलब काइनेटिक एनर्जी में.
तो इसलिए टैक्यन बोलते हैं.
नहीं सर, एक्चुअली वो सर ओरिजिनेट हुआ है हमारे स्ट्रिंग थ्योरी से ओरिजिनेट हुआ टैक्यन.
उससे पहले ही आया था
सर. अशोक सेन जी ने इंट्रोड्यूस किया अपने पेपर में.
सुदर्शन समय को सुपरसिमेट्री नहीं था, ये नेगेटिव मास पे.
हाँ, वही मतलब उसके उसमें आता है.
तो मास का नेगेटिव हो जाती है. क्विंटेसेंस क्या होती है
सर? क्विंटेसेंस मतलब एक स्केलर फील्ड से वो मतलब निकला सर. ये
वो फर्क क्या है? सी एवरीवेयर देयर इज अ स्केलर फील्ड. d mu phi is the Lagrangian.
Sir,
kinetic energy. V of phi is the potential. ठीक है? प्लस m स्क्वायर लिया तो रियल स्केलर फील्ड हो गया, माइनस m स्क्वायर लिया तो टेकियन हो गया. क्विंटेसेंस कब होती है?
सर इसमें डायनामिकल बिहेवियर करती है और ये हमारा कैनोनिकल फील्ड होता है. और इसमें सर हमारी जो क्या होता है कि इसमें काइनेटिक टर्म हमारी नेगेटिव नहीं आती, मतलब इसमें नेगेटिव मास नहीं आता हमारे क्विंटेसेंस.
फैंटम क्या होती है?
सर फैंटम और क्विंटेसेंस मतलब लगभग सेम ही बिहेवियर है, लेकिन डिफरेंस क्या है कि जो फैंटम में है सर हमारी नेगेटिव टर्म आती है काइनेटिक एनर्जी में, जो कि क्विंटेसेंस में नहीं होती है.
सर फर्क क्या पड़ेगा?
सर फैंटम जो है सर वो सुपर टाइम वो बिग डिप को मतलब बताता है. और
okay, no, I am not asking how these fields are. Analysis is going to work in your acceleration of the universe के बारे में नहीं है.
फैंटम इज ghost like particle.
Ghost like particle. So what would be the character difference?
Sir, the main character difference is only this that कि जो ये मतलब अर्ली यूनिवर्स को सही से एक्सप्लेन कर पाता है इन्फ्लेशन एरा को, जो भी कंडीशंस करता है वो फैंटम में ये दिक्कतें थोड़ी रहती हैं सर.
सेकंड पार्ट ऑफ द थीसिस में अपने कंक्लूजन में भी लिखा है
फाइन ट्यूनिंग क्या है सर. फाइन ट्यूनिंग प्रॉब्लम इज दी लाइक दैट दी जो ऑब्जर्वेशनल वैल्यू थी लैम्डा सीडीएम की.
नहीं एस्ट्रोनॉमी से मत लगाओ. स्केलर फील्ड थ्योरी में, नॉर्मल फील्ड थ्योरी फॉर्मलिज्म में
सर
that's the one question. Let me ask the question first. What is fine tuning problem? Is there any field theory example where this is not an issue? एक एग्जाम्पल है जहाँ पे फाइन ट्यूनिंग प्रॉब्लम नहीं है. ऐसा कोई थ्योरी पता है?
सर अनपार्टिकल डार्क एनर्जी में से ये थोड़ी मतलब दिखते हैं, क्वांटम फील्ड थ्योरी से इसको रिलेट किया गया था.
फाइन ट्यूनिंग क्या है? क्या ट्यून करने में सी व्हाट इज द मीनिंग ऑफ?
मतलब होता कि जो लैम्डा जो सीडीएम की जो वैल्यू है दैट इज 10 की पावर -120 समथिंग प्लैंक्स मिनट, लेकिन सर वो काफ़ी स्मॉल आती है एज कम्पेयर टू जो क्वांटम फील्ड थ्योरी का बोलते हैं, उसका वो मैच नहीं करता सेल्स को. ये
ठीक है. एक छोटा क्वेश्चन सर, टोपोलॉजिकल ऑब्जेक्ट्स के बारे में सुना है कुछ?
सर
टैक्यन का बात आपने सुना है. दिस फाइनाइट अमाउंट ऑफ वर्क एक्चुअली, कॉस्मिक स्ट्रिंग्स एंड कॉस्मिक वर्टिसेस. तन्मय वाचस्पति, देयर इज ए GTR related person who worked in this area.
जी सर.
So cosmic strings and their contribution for in general के लिए काम आ गया तो देख लेना. एक और एक चीज बात किया, लास्ट क्वेश्चन, स्ट्रिंग थ्योरी के बारे में कुछ बात कर रहा था, पता है कुछ?
सर मतलब
क्या लिखा है? स्ट्रिंग थ्योरी सर्वाइव्स कॉम्पैक्टिफिकेशन वगैरह वगैरह करके लिखा था टुवर्ड्स द एंड ऑफ द थीसिस. वैसे ही लिखा है या कोई कुछ आइडिया है?
एक्चुअली टेक्यॉन से थोड़ा लेट कर रहा था क्योंकि सर डीप ब्रेन कंडीशन आती है उसमें ना, एक मतलब जो अनस्टेबल आता है कि मतलब ओपन स्ट्रिंग्स उसमें रहते हैं, लाइक जैसे हम कोई बॉल को एक इस पर माउंटेन में रखते हैं कि वो मतलब 10 तरह का एक उस तरह की प्रॉब्लम इसमें टेक्यॉन में थी. सर उतना
पता नहीं
सर, उतना है नहीं. अच्छा
आपके दोनों क्वेश्चन दोनों साइड पे हो गए.
हाँ
दूसरे एग्जाम में.
हाँ जी हाँ ठीक है. आगे की
सर डार्क मैटर इज द इनविजिबल फॉर्म ऑफ मैटर विच डोंट रिफ्लेक्ट, डोंट emit लाइट एंड डोंट ऑब्जर्व लाइट. सर एक्चुअली मतलब इनविजिबल फॉर्म ऑफ मैटर है जिसको मतलब जो ना रिफ्लेक्ट करती है, ना emit करती है, ना ऑब्जर्व करती है लाइट को.
How can you extend your work in future?
सर एक्चुअली आई डिड माई जैसे मैंने अपना काम किया है दैट इज आवर फॉर कपल फॉर CD मॉडल दैट इज, बट इन फ्यूचर सिमुलेशंस इसमें हो सकते हैं, मतलब हम इसको ऑब्जर्वेशनल कंस्ट्रेंट्स डाल के वो चीज़ मतलब देख सकते हैं कि मे बी इट प्रोवाइड गुड रिजल्ट, भी डाटा है तो उसको कर सकते हैं. तो मेरे सर जो काम था वो मतलब थ्योरेटिकल काम है, इसमें हम ऑब्जर्वेशनल के साथ लिंक कर सकते हैं. अगर हम इसमें सिमुलेशन देखें कि हम सिमुलेशंस ऐड करके इसमें क्या इफेक्ट आ सकता है इंटरेक्शन में है या नहीं है, तो वो चीज़ फ्यूचर वर्क है, मतलब कर सकते हैं.
ये काम और भी हो सकता है.
जी सर.
क्योंकि बीच में गैप भी रखा जा सकता है.
जी सर.
Have you thought about using artificial intelligence in this area, AI?
Sir,
Lot of equations you are using, lot of models are there.
सर AI नहीं किया इसमें, मतलब वो खुद ही सॉल्व किए हैं, मतलब हैंड से।
कुछ लोग कर सकते हैं इसमें?
हाँ, हो सकता है।
You are using actually.
यस।
Anybody?
Dark energy, like nanotechnology, and I mean, fascinating
हाँ,
words,
मतलब
just to attract everyone.
It's not
Or is there any particular?
No, dark energy, dark matter. See, everything is correct. What is it that something is missing? The pressure calculations ऐसे calculate कर रहा है तो condense होना था, नहीं हो रहा है। ये क्यों नहीं हो रहा है? Something is holding it back. You don't know what is that something, you call it as a dark. The interaction of that with, see, that's a problem. This interaction, हमेशा interact होने से ही system के बारे में पता चलता है। So this is something which is so weakly interacting that किससे क्यों हो रहा है समझ में नहीं आ रहा है। स्टैंडर्ड मॉडल ठीक है, स्टैंडर्ड सोलर मॉडल, स्टैंडर्ड कॉस्मोलॉजिकल मॉडल, ये सब ठीक है, तो ऐसे होना चाहिए, ऐसे दिख रहा है, लेकिन आपका मॉडल ठीक नहीं चल रहा है। So then you put in a word that there is some matter, there is something which is weakly interacting, which is not available for observation. उसको डार्क।
It's just similar to the black hole also, because something must be there. That's why some body is actually.
But that has been observed now. Now the black hole has been observed. Conclusively, people know that there are
From the
physical black
calculation.
holes.
From the calculation.
No, Einstein told you that mathematically there should be a black hole, and physically people have found out that leading to that observation, and black holes have been observed. People have made observations and they found that if the black hole is there, it should move like this, etc., and they got the results. पहले mathematical calculation ही short cell radius होता था वगैरह है, so now it's very recently. The other day there is a beautiful good gentleman इधर मोहाली में है, जगजीत बांगला, वो नार्लिकर का ग्रुप का यूका से है, and he has made a presentation of observation. How do you observe black hole? What are the signatures you have got so far confirming that black holes do exist? कौन सा गैलेक्सी में है वगैरह वगैरह. It is available in the YouTube also in his lecture. So 2-3 candidates are already there, that these are the black hole candidates.
So black hole, was there, I mean, this word in your dictionary?
No, इसका नहीं. Dark energy, dark matter.
No, actually, this is I have asked so many times, I mean, about the dark energy. That's why I'm thinking not to ask or not to ask.
No, lack of interaction is dark, something which we don't know about. So that you label it as dark. So interesting observation, purely theoretical है. अब मैच आएगा, मॉडल अच्छा बनेगा नहीं बनेगा, डिपेंड्स.
Training. So, conclude.
Okay, should we call him a doctor?
Yeah, let's congratulate.
Basically, we recommend.
The board recommends. The board recommends the award of degree. Congratulations.
Thank you, sir. Thank you.
Congratulations. Thank you. Once again, I would like to sincerely thank Dr. C. Kumar for gracing us today as an expert. On behalf of the department and the university, I express our deepest gratitude for your valuable time and your gracious presence. We truly hope to have more opportunities in the future to benefit from your expertise. Thank you once again, sir.
Thank you. Thank you for contributing.
फोटोग्राफ भी लेना है हमने.